Hi everyone. We are going to carry on with question 5. We are going to carry on with question 5, grade 10 final exam questions. This is our third video. First video, we answer question 1. Second video, question 2, 3, 4. Now we are going to carry on with question 5. This question, let's see what they ask people. It's also about motion. Now we are going to use equation of motion. In question 4, they said without using equation of motion. Now we are going to use equation of motion to answer this question 5. Let's see what kind of motion we have. First of all, people, let's see, we can check question 15 meters per second in 60 kilometer per hour speed zone. Okay. First 1 second going with constant velocity, 15 meters per second. After that, 3 seconds velocity decreasing and stop. So we have two different motion, uniform motion in 1 second, and then negative acceleration for 3 seconds. This is our motion. Let's see what they're going to ask. First of all, for this kind of question, people, we should choose our initial velocity, final velocity. If you have constant velocity, what is velocity? So you can just write on diagram everything. V initial, even V final, same for 1 second. You have 15 meters. And after 1 second, for 3 seconds, we have V initial equals 15 meters per second. And then when you come to final position, we don't know which position in 15 meters. So V final equals 0 meters per second because he has to stop before hitting the wall. So just he has to stop from 15 to 0. Initial is 15, final is 0. And time is 3 seconds. Acceleration, we don't know. Okay. So this, and then we have displacement, but total displacement, total distance, we know. Let's see what they ask. Let's continue. Question 5.1. The equation of motion are only valid for motion at constant something in something. First of all, we know, people, equation of motion, all of them, constant acceleration. So 5.11 is acceleration. Acceleration is our answer in a straight line. In a straight line. This is our answer, people. Acceleration in constant acceleration. We need constant acceleration, positive, negative, even 0, it's fine, but we need constant acceleration to use equation of motion. Next question, in question 5, let's see what else they ask. The driver of delivery van exceed the speed limit or not? Okay, so speed limit is 60 kilometers per hour. Okay, speed limit is 60 kilometers per hour, and then our speed is 15 meters per second. 15 meters per second. For now, we cannot say is just exceed speed limit or not. We should convert first from meters per second to kilometers per hour. We are using this easy way, people, times by 3.6. So 15 times 3.6, getting 54 meters per second. Why 3.6? Because we are using this option, people, meter per second. We know 1 hour equals 3,600 meters, and then 1 kilometer equals 1,000 meters. So 3,600 over 1,000 is 3.6. We are getting 3.6. If they ask from meter per second to kilometer per hour, divide by 3.6. Just using 3.6 to convert units from meter per second to kilometer per hour. we are using just multiply by 3.6, and then from kilometer per hour to meter per second, divide by 3.6. Okay, so what can we say? What is our answer? Answer is no, because our speed is 54 meters per second, less than 60 meters per second. Answer is no, because 54, we know, less than 60. Done. So this is our answer for 5.2. Let's continue with next question. Let's see what they ask. Calculate the distance, okay, for 1 second. Reaction time. So we are going to calculate our distance. What was the formula for distance? Distance equals, we can say, symbol, distance, symbols, some people using S, some people just writing distance. We can use V times T, and then what we have, what is V? 15 meters per second times 1 second, and then you are getting 15 meters. Distance is 15 meters. Or you can use other formula to calculate distance. It is displacement formula, but we can use for distance also. V initial times delta T plus 1/2 times A times delta T squared. So this formula, from formula box, you can get it. V initial is 15, delta T is 1 plus 1/2. Acceleration is 0, because constant velocity means acceleration is 0. Delta T equals 1, but this is 0, it's gonna just all gone, and then you are getting 15 meters. Other formulas also you can use to calculate displacement, but this one is enough. So we have different options. Just use equation of motion, formula box, and you can get it. Next question, 5.4 now. They're asking you, will the van stop before crossing? So to know that, we have to calculate total distance, people. We have already, how many meters? We have already 15 meters for 1 second. We calculate already in question 5.3. We have 15 meters. This one, just leave it here. And then let's calculate for 3 seconds. What we know for 3 seconds, V initial is 15 meters per second. And then V final equals 0 meters per second. Delta X displacement equals 50. It is given here, 50 meters. So we are looking for what? This total, oh, sorry, this is not displacement. This is because this, we cannot use this 50 meters, because 50 meters for total, all of them. Okay, we are looking for displacement for 3 seconds. We know time, we know initial position, we know final position. To calculate that, we have different options, people. You can use delta X equals, this one is easy one, delta X equals V initial plus V final over 2 times delta T. So if you use this one, you're going to get displacement for 3 seconds. Let's see, V initial is 15 plus 0 over 2 times delta T is 3 seconds. When you calculate, you are getting 22,5. This 22,5 for 3 seconds, not 50, we did mistake there. So 22,5. So what's our total distance? We can just add both of them for 1 second and 3 seconds. We're gonna just add and getting total distance 15 plus 22,5 is 37,5 meters. What was our total distance, people? It was 50. And then moving only 37,5. And what's our answer, people? With the when stop before crossing, answer is yes. We can say yes, because 37. He will stop before the crossing. This is our answer, people, for 5.4. And then let's see what else they're asking here. Question 5.5 now, 5.5. Will the stopping distance of the van increase or decrease when the road is wet? Okay, road is wet, it means we have less friction. If you have less friction, your stopping distance, of course, will increase. This is our answer, increase. Why? Because for the, what's going to happen, people, it's difficult to stop. We can say that for the same change in velocity, stopping time will increase, because stopping time will increase. Stopping distance will increase. Why? Because stopping distance, stopping time will increase, people. Are they asking give reason? Yeah, they said briefly explain how you arrived at this answer. Because the stopping distance, stopping distance, they're asking already, stopping time will increase. This is our answer for question 5.5. Stopping time increase. So just think about a slippery road, people. Of course, that's just stopping distance will increase. Why? Just think about that. You are just walking on the road, or you are on ice. So what's going to happen? Of course, it's difficult to stop on ice. Stopping distance and stopping time increase. That's it. So let's continue with next question. Now we are going to question 6. In question 6, we have energy question. So for energy, first of all, people, let's remember what kind of energy questions we have. First of all, we have mechanical energy, potential energy, kinetic energy, and conservation of mechanical energy. What is potential energy? Energy of motion. And kinetic energy, so potential energy, energy of position. Kinetic energy, energy of motion. Mechanical energy, potential plus kinetic. Potential plus kinetic. Let's see now what they ask in this question. First position, okay, point A, and then object is going to B, speed up, and then going to C. From C, we have friction, and slowing down, stop at point D. First of all, okay, this motion we have. Let's see what they ask. 6.1. Write down in words, okay, principle of conservation of mechanical energy. What we know about conservation of mechanical energy? Mechanical energy is potential plus kinetic. Potential plus kinetic. We can write, we can say EM equals EP plus EK. So potential equals EP plus EK. EM equals EP plus EK. What is EP, people? EP is potential energy, stored energy, energy of position also we can say. For this one, formula of EP equals, formula of EP is mgh. They don't ask you formula for now, just let's explain and then we can answer 6.1. EP equals energy of position, mass times gravitational acceleration times height. G is constant, gravitational acceleration 9,8 meters per second square, and then h is height, m is mass, we know that, and then gravitational acceleration is 9.8 meters per second. When you come to EK is energy of motion. EK equals half mass and V square. So mass is here, velocity square. So if there's no speed, no velocity, your kinetic energy is zero. Mechanical energy is potential plus kinetic. So let's write our answer now for this one. Mechanical energy, we know now. But now they're asking you people, conservation of mechanical energy. Total mechanical energy remains constant in a closed system. Maybe we can just type it, conservation of mechanical energy. The total mechanical energy is, mechanical energy, let's say, remains constant in a closed system. In a closed system. So this is our conservation of mechanical energy. It is very important for final exam people. Total mechanical energy remains constant in a closed system. Please remember conservation of mechanical energy. We know mechanical energy already. What was the mechanical energy? Potential plus kinetic, sum of potential energy and kinetic energy. And then conservation of mechanical energy is total mechanical energy remains constant in a closed system. This is our answer for 6.1. Only this one is answer, but we explain more. So let's continue with next question. Now, in question 6.2, let's see what they're going to ask. In 6.2, okay. Calculate the gravitational potential energy at point A. Gravitational potential energy formula, we said EP equals M times G times H. EP equals M, G, and H. M is given in this question, let's see, 0.2 kg, 0.2. H, G we know already 9.8, and H's height is also given 0.8, 9.8 for G, 0.8 for height. So let's calculate 1,568 joules. Done. Gravitational potential energy, calculating by MGH. That's it. Let's continue with next question, 6.3. They said at point B, speed of object 3 meters per second. Okay, it is given. Initial velocity, it was 0 at point A. VA, we can say VA equals 0 meters per second. And then VB for this position, it is 3 meters per second, as you see, speed up, and then velocity increasing. What they said, use the conservation of mechanical energy. We said conservation of mechanical energy is constant. So EMA equals EMB. This is conservation of mechanical energy. Mechanical energy is constant, remains constant in a closed system. So EMA equals EM2, EM1 equals EM2. Let's calculate, let's see what they ask first. Calculate the vertical height at point B. Okay, we are gonna calculate this height. Okay, how can we calculate height at point B? Object just going down. What we know, initial velocity we know, velocity for B we know, and we know height for A, asking height at point B. Okay, let's continue with this formula. EMA is equal to EPA, potential for point A, plus kinetic for point A, EKA we can say, or you can say EP1, EP2, still same. And then EPB plus EKB. So let's continue. EPA, what was the formula for EPA? EPA equals M times G times H. Which H, people, now we are using? A. Height 4.8. And then 1/2 times mass times VA square. So we are writing formula for potential and kinetic. And then let's continue with B, M times G times H. B plus 1/2 mass times VP square. So we are writing all potential and kinetic. And then, people, what we know, VA is 0, so we can say this all 0. And then anything else 0, nothing else, we'll carry on now. Mass, and then you can just cancel for all mass, people, because we have equation and both sides we have mass. You can just cancel mass. After that, let's write what is left. G is left 9,8. HA is 0,8, okay, 0,8 equals G is 9,8 times HP. We don't know, we are going to calculate it now. Let's say just H plus 1/2, M is gone. So what we have, 3 squared. And when you calculate from this equation, people, what you are going to get, what we're going to do first, multiply this one and then this 9/2 coming this side minus, and then H equals, when you calculate this equation, you are getting 0,34 meters. So we calculate height. For this kind of question, people, as you see, we are using conservation of mechanical energy. We know what is mechanical energy. Mechanical energy is potential plus kinetic. And then you just cancel some, if something is 0, you are calculating height. So they can ask, maybe next time, they can ask you velocity for point C, and then you can just use same method, conservation of mechanical energy. Let's see what else they're asking. 6.4 now. 6.4. Now, velocity for C is given. Okay. Velocity VC. VC is equal to 3,96 meters per second. And what else we know, people? Okay, write down energy. Okay, nothing else for now. But we know, okay, we know is velocity for C, 3,96 meters per second. It was 0 here. VA, do you remember? It was 0 meters per second. Now it is 3,96. For B, it was 3, and increasing and going down. And then after C, we have friction, people. Friction between D and C, slowing down. Final velocity will be 0. Maybe in the next question we can explain that. Okay. So conservation of what? Sorry, energy conversion. What energy conversion? Because of friction, mechanical energy change to convert to heat energy or sound energy. We can say, just let's write mechanical energy converted to heat, even we can say sound energy. That's it. What energy conversion? Because of friction, people, making heat energy. Mechanical energy, you know, potential and kinetic. Potential and kinetic energy convert to heat energy, because at point A we have potential, and the potential change to kinetic, and when you come to C, there's no potential, only kinetic, but still we can say mechanical energy converting, energy changing to heat energy, from mechanical to heat. Let's continue with next question. Now calculate acceleration of the object. if objects stop at D. So is it given an object? Okay. It is going down and stops at point D. It is given in question. As you see, people, stops at point D. Okay. So we can use only from C to D. From C to D. For C, V initial equals 3,96 meters per second. And then V final equals for D 0 meters per second. And what we know delta X. Displacement equals 2 meters, but we don't know acceleration. We don't know time, but we are looking for acceleration. So they said calculate the acceleration. Okay. Now we can calculate the acceleration. If they ask time after calculating acceleration, we can get time also. For now, asking acceleration. This formula is best. If you don't know time, you can use this formula to get acceleration. This is our formula. Let's write what we know, 0, V final, and 3,96 plus 2 times 8 times 2. And when you calculate, you are getting acceleration. Acceleration equals negative 3,92 meters per second squared. This negative showing you direction, people. You can say acceleration equals 3,92 meters per second squared, and then opposite to the direction. Opposite to the direction of motion. Opposite to the direction of motion. Direction of motion. Okay, so this is our question 6. In question 6, people, we calculate, we have learned potential energy, kinetic energy, mechanical energy, thought, and then conservation of mechanical energy. So what was the potential energy? Energy of position. Kinetic energy, energy of motion. Mechanical energy, potential plus kinetic. And then conservation of mechanical energy. What was it? Conservation of mechanical energy. Mechanical energy remains constant in a closed system. This is our question 6. Today we have done question 5 and 6. Next lesson, we are going to carry on with question 7. Next lesson, we are going to carry on with question 7. So we can finish our video today. See you next lesson.